Hello everybody. Okay, we're going to have a look now at what some example questions could look like when we're asked to explore a sine or cosine function. So first of all, we're going to sketch some graphs and we're going to sketch them between a boundary of 0 to 2 pi in the x direction. So let's see if we can remember what these different things mean. So we'll do this, we'll go through them all at the same time. So first of all, if I have a x minus pi over 3 inside that sine function, it means it takes the original sine function and it's going to translate it to the right by pi over 3. Okay, so let's write that down. To the right, pi over 3 from the original. Now, if we look at b, we're going to take the original cosine, and what will this number do? It is going to affect the period of the graph, or the time it takes to repeat itself. The original is usually 2 pi, but now we're going to divide that by 3. So the new period is going to be 2 pi over 3. Let's look at C. Well, two things are going to happen to the graph of C. First of all, it's going to move up 1. It's going to go up 1 place. And as well as that, we're going to move to the left by pi over 6, because that is a plus sign, so we move to the left of pi over 6. And then finally, D, well, if we have a minus sign there, it's like multiplying the magnitude of this thing by minus 1. That means it will reflect. Okay, if once it was at 1, it will now be at minus 1. So it's going to reflect in the x-axis. Okay, now we've got to draw these things. So let's think about drawing each one of these 4 different examples and see what they look like. Okay, so the first one, well, we are moving to the right pi over 3. So if the sine graph usually starts from 0, now at the point pi over 3, we're going to be at our 0. So it's going to look something like that. Of course, we're not going to get quite to the end in our boundary between 0 and 2 pi. But we better go backwards, okay, as well, and repeat itself. So it's going to look something like this, with that max staying at 1 and the minimum staying at minus 1. So there is our first little diagram. Okay, the next one. Well, we are going to have a period of 2 pi over 3. Now, another way of thinking about this is if we're going to contract the period and reduce by a scale factor of 1/3, then really, rather than having one oscillation or period within the boundary of 0 to 2 pi, we're actually now going to be able to fit 3 in there, right? So if we think about that, we're going to have the same function as usual, okay? So starting at 1 and going down as low as minus 1, but it'll happen 3 times in the original period of 2 pi. So 1, 2, 3. Okay, so there we go. That will be the correct diagram. And the oscillation, okay, 2 pi over 3. And it will repeat itself again, look, at 4 pi over 3. And of course, 2 pi is equivalent to 6 pi over 3. So this does work. Okay, C. We have a cosine graph again this time, and we are moving up 1. So that means that rather than oscillating between 1 and minus 1, we've got that principal axis here, okay, and that is at the point 1, which means if we're going to keep the amplitude the same, it will go as high as 2 and as low as 0. So we're going to be looking something like that. Okay, as well as that, though, we are going to be moving to the left by pi over 6. So if we think of the original cosine graph, maybe we can say the top max will be at negative pi over 6 rather than being at 0. So if we come down from that point and we're going to draw this thing, then we are going to have something like this. Okay, and then of course, rather than finishing at the peak at 2 pi, we'll have to go a little bit further down because we've dragged it to the left. There will be our 2 pi, okay? In fact, that peak there, look, that was going to be at 11 pi over 6, okay? So there is our part C. And then finally D, we've got sine x, but it's a reflection in the x-axis. So rather than going up from 0, it's going to go down from 0. We're going to have exactly the same period of the graph. It's just a total reflection of the original graph. So we're at 2 pi, going as low as minus 1, and as high as 1. Do forgive my poor diagrams. Hopefully you understand what they mean. Pay attention, though, to the labeling, where things are and what's been sort of highlighted. That's what the examiners are going to be looking for there. Okay, so let's do another one. This time we're going to sketch the cosine graph of 3 cos 2x. So what is happening here? So let's pay attention. First of all, we are stretching this thing. The amplitude is going to be 3. And we are reducing the period of the graph. So we're taking the original 2 pi and we're dividing it by 2. So the new period of the graph is going to repeat every pi radians. So if I am drawing this one out, between 0 and 2 pi, we're going to have 2 different oscillations happening in that boundary as it repeats every pi. We're going to go as high as 3. We're going to go as low as -3. So we start from the top because we are a cosine graph, and we'll get back to the top halfway through, look at pi. So our graph is going to look something like this, repeating twice, having a period of pi radians. Okay, there we go. On to the next one. Find the unknowns for this function. Okay, so we've got, this is a little bit difficult now. This is a different sort of question altogether. No graph drawing here. We just know some points that exist on a certain specific sine function. So why don't we start putting some numbers in and see what happens. So we've got a sine x plus d. Well, we know that when x is pi over 2, the outcome of that, the function is worth 8. So subbing that in, we could say 8 is equal to a times sine of pi over 2 plus d. And we should know from our unit circle that sine pi over 2 is just 1. So this can be reduced down to 8 equals a plus d. Now we can put the other point in as well and see what happens there. So I know that I get a half as my outcome if I substitute in 7 pi over 6. Okay, plus the d. Now we can work this out again using the unit circle, and if you can't remember this one, you can be forgiven for that. If we do a quick unit circle diagram, 7 pi over 6 is going to be there, look, okay, and we are looking for the sine, which is the y coordinate. Okay, we have gone down -1/2 there, so we can replace that with a -1/2. A half is equal to -1/2 a plus d. Okay, now we have, perhaps we should multiply that all by 2 to make it look a bit nicer. So let's replace that with 1 equals -a plus 2d. And what we've done here, we've got 2 simultaneous equations to solve. Okay, now if those are both true, maybe we could add them together and eliminate those a's. So if I call that 1 and I call this 2 and I do 1 plus 2, I will have 9 is equal to 3d, which tells me that d is equal to 3. And if I go back to one of the original equations, the top one perhaps, if d is 3, I can hopefully clearly see that a is going to be 5. There we go. We have the answer. D is 3 and A is 5. Okay, moving on to our final example, question number 4. Okay, find the equation of this sine function. Well, first of all, what do we know? Well, we can see that our principal axis is at y equals 1. So we certainly have a +1 that has happened to the original sine function. We also can see that the period of the graph is now pi. So it was 2 pi, now it's pi. It's been divided by 2. So that means we're going to have a sine 2x involved in this function as well. We can also be pretty confident that our amplitude is 1. So there is nothing in front of it. There's just a 1 there because the amplitude is still 1 as is the original. So we can say our function is perhaps y equals sine of 2x plus 1. Okay, that should be enough to answer the questions. Have a go at these ones, please, and good luck.